Good morning to all. I am Jamuna, working as assistant professor in Artificial Intelligence and Data Science Department in Erode Segundar Engineering College. Today we are going to discuss a topic in the title Critical Section Problem in the subject of Fundamentals of Operating System. First of all, why we are going for this critical section problem? We are dividing the process into two types, that is cooperating process and independent process. Independent process means we know that the name itself we can easily understand it won't depend on other process. Then there is no deadlock or inconsistency occur in independent process. But in cooperating process, the cooperating process means one process output will affect other process, and cooperative process are share something between them. So there is a inconsistency or deadlock will arise between the process. To to avoid this problem, we are synchronizing the process. By using that, for synchronizing the process, we are using critical section problem. What is a critical section problem? First, we have to consider a system consists of n process. That means P0, P1 up to Pn. That is, there are n number of processors running in a system. Each process has a segment or portion of code. That is called a critical section. For example, each process has a full of programs. In that program, we are taking only a small portion of the code. That small portion or small segment is known as critical section. That critical section may it may process something, maybe for example changing a common variable or updating a table or writing a file. Otherwise any process it is doing, or otherwise it will share the variable. Like that, the segment or portion of the code will do some process. When one process executing in its critical section, no other process is to be allowed to execute in its critical section. That means critical section is only the process will be executed in critical section. While running the critical section, other process we cannot execute in critical section. That is, no two processes are executing in their critical section at the same time. For example, we are considering the two processes P1 and P2 that is sharing the same variable. The variable name is called share. Both the process sharing the same variable means there is inconsistency of data will arise. To avoid this, we will go for critical section problem. And what are the rules in critical section problem? We are dividing the small portion of the code, that is critical section source code, is divided into 4 sections. I mean critical section, entry section, exit section and remainder section. First section, critical section. What is that critical section means? Each process must request permission to enter its critical section. An entry section, the section of code implementing this request is the entry section. That means the code have to get request from the entry section to get into critical section. And exit section means the critical section is followed by exit section, and remaining code will be in remainder section. So there are 4 sections are there. This is a general structure of this do while loop. Inside that entry section, that means while entering into critical section have to get permission from the entry section, and critical section code will be executed in critical section. And exit section is followed by critical section, and remainder section, the remaining code will be executed in remainder section. And there are 3 requirements are there to solve this critical section problem. What are the requirements are? Mutual exclusion, progress and bounded waiting. And first we will learn about what is a mutual exclusion. Mutual exclusion means if process P1 is executing in its critical section, then no other process can be executing in their critical section. That means it is a mutual exclusion. At the same time, only one process will be executed in critical section. Second one, progress. If no process is executing in its critical section and some process wish to enter their critical section, then only those processes that are not executing in their remainder section can participate in the decision on which will enter it critical section next, and this decision cannot be postponed indefinitely. That means now in first point we learned that in critical section at the same time only one process will be executed. In second point what we are going to learn means in critical section there is a no process is executing in critical section. That means critical section process, the critical section is empty. At the time there are so many processes are wish to enter into critical section. There are so many processes are waiting. They are wishing to enter into a critical section. But which process that is not in remainder section, that process only can take the decision of which process will be entered into a critical section. That is known as progress. That means which process that is not executing in the remainder section, that process can take the decision that which process will be entered into a critical section, and this selection that cannot be postponed, that will happen very immediately. And third one, bounded waiting. There exists a bound or limit on the number of times that other processes are allowed to enter their critical sections after a process has made a request to enter its critical section and before that request is granted. That means here there is a limit. That means how many number of times that other processes are allowed to enter into a critical section, that are monitoring. That is a bound, there is a limit. Because why we are monitoring this means if the process waiting for indefinite time means there is a starvation problem will arise. So here the limit of process to enter critical section are maintained. So some limit of process only can enter into a critical section to avoid the waiting starvation problem. And Peterson solution, it is the classical software based solution for the critical section problem, but it is not work correctly on modern computer architecture. It is a classical software based solution, but however it provides good algorithmic description of solving the critical section problem and illustrates some of the complexities involved in designing software that addresses the requirements of mutual exclusion, progress, and bounded waiting requirements. So the Peterson solution is a very classical software based solution. Then also it is a very algorithmic description that will solve the all the three requirements. Already we learned that mutual exclusion, progress, and bounded waiting. All the three requirements are satisfying here by using this Peterson solution. See the same points and listen here. Peterson solution is restricted to two processes that alternate execution between their critical section and remainder section. That means let us take two processes Pi and Pj. Peterson solution requires two data items to be shared between the two processes. There are two data items are there. What are the data items are? Turn and flag. These are the two data items. Turn is a integer data type. Flag is a boolean data type. Then integer means it will return integer values. Boolean means it will return true or false. First, that's int turn. Int turn, it indicates whose turn it is to enter into critical section. Boolean, flag. This flag is used to indicate if a process is ready to enter into a critical section. For example, if turn equal to I means that corresponding process Pi, that Pi process turn to enter into a critical section. And if flag of I, that flag of I is true means then Pi process is ready to enter into a critical section. The value of flag is true means the process is ready to enter into a critical section. The value, the flag of 2, flag of 5, that value is, the value of flag is true. That means the process is ready to enter into a critical section. It is a very humble algorithm. Why we are telling that it is a very humble algorithm? For example, two sisters are there. If they are going into a one temple, in the temple one person only can enter into the temple at one time. Like that, the the door is there. Like that, the door is there. So two persons at a time, two sisters at a time, they trying to enter into a door. But the elder sister told to the younger sister, it's okay, you go first, like that. So elder sister is very humble. Like that, this Peterson solution also very humble algorithm. See that algorithm. First int turn and boolean flag. First we will see the structure of process Pi in Peterson solution. This is the process of Pi and this one process of Pj. First Pi, do loop, do while loop, and flag of I is true. That means flag of I is true means process Pi only executing now. Pi structure only is there. Next turn equal to j. Listen here. Here two data items are there, flag and turn. If one process is true and next turn equal to j, then pj process also is ready to execute. That means it is a humble, we told no. The same like two sisters are there and one sister told the younger sister to tell that you can go. Same like here, PA process true. That means flag of I is true, then PA is going to execute. But PJ process is giving the chance to the PJ. So this also very humble. So we are telling that turn equal to J. Then PJ process also is ready to execute. Then while flag of J and turn equal to J. That means flag of J and turn equal to j. Here turn equal to j means then pi process ready to execute, pj process ready to execute. Then we will see the structure of pj. Here the same do while loop. In first flag of j is true, then yes, it is a flag of j is true. The same, it is very humble, so giving chance to turn equal to I. And in this critical section problem, at last the turn value is become j means or I means that is the final value of turn. For example, now turn equal to I, then that is the final value of turn. Okay, then flag of j equal to true, the turn equal to I. And listen, pi process while flag of j, that flag of j also true, and turn equal to j, but turn equal to I in process pj, so it is a fault. Listen here while loop will end with a semicolon. What is the meaning for this semicolon? Means there is a loop in that condition, in that line there is a loop is there. It is end with a semicolon. What is the meaning for this semicolon? Means if the loop is true means it will continue its looping. If it is false means it will go for a critical section. So we will check it is true or false. Flag of j is true and turn equal to j, so it is a false. And statements means both also should be true, so here it is a false statement, so it will move for critical section will execute. And then flag of I equal to false, that means pi process will be will be terminated. Okay, and then remainder section will be executed. Next we will go for pj process. While flag of I and number equal to I, and then flag of I means that is a false, and turn equal to I. And what is the turn value? Here turn value is I. So one condition only true, and then the loop will be moved to the critical section, and the critical section will be executed, and then flag of j equal to false. So that process is end, and then it will execute the remainder section.